So 2 videos ago, I made a video about how AI works, about how LLMs work. And I explained in that video that LLMs are not thinking. They are basically running a giant probability model, which is in essence pattern matching. And one of the most common comments on that video was a really good one. Isn't that just what people are doing when they're thinking? Aren't we just pattern matching? And then recently, the internet has been buzzing about how AI models scored gold at the International Math Olympiad, which is it essentially was solving these problems that humans were stumped on for days. And this is really an insane development and is opening up important new conversations about what AI means, how is it actually working. And there's this big risk for all of us that as this technology washes over the world and makes us all dumber, by the way, that if we don't understand the essence of this technology, how it works, what it's good for, and what it's not good for, we are either going to be replaced by the technology or we're going to be replaced by somebody who really understands the technology well. So what we're going to do in this video is we're going to explore the 8 essential kinds of reasoning. We're going to talk about what each kind of reasoning is, how it works, what AI does well today, what humans do, and then also what is AI going to do tomorrow as these models continue to develop. And at the end of this, so we'll rank each of these by, how well do they do today? Very scientific rating of red, yellow, and green. And then at the end of this, I'm going to share 5 important takeaways about what AI getting these gold medals actually means for you, what it actually means for your job and your career, and what it means for your life and work as complex reasoning starts to become automated away by AI. So for anyone who missed the previous video, here's a 30-second snippet of how LLMs work. LLMs, large language models, are what you typically think of when you think of AI. That is what Grok, ChatGPT, Gemini, and so forth are. And what these tools do is they do not actually think. What they do is predict the next word based on patterns in massive text data. So they're calculators trained on language, and that's the way the models work today. Now, there are new innovations which are adding and evolving these technologies, but that's what they do right now. So let's jump right in and start talking about our 8 kinds of reasoning with the first. The first, I had to cover them twice so that you couldn't see through. Suspense. The first is deductive. All right, deductive reasoning is basically drawing conclusions from a general set of rules. So you could think of this like in a math example. You could think of something like all triangles have 180 degrees. This is a triangle, so it's going to add up to 180 degrees. Or you could do this with something common knowledge like, all credit cards charge interests, and I have a credit card, so then my credit card must charge interest. That's deduction. You start with a rule and then you apply it to a specific case. And this is something right now that AI does really reasonably well. So AI today is really good at following rules. So if you give it clear instructions, it is going to perform those instructions perfectly. And unlike people, it's not going to get lazy. It's not going to skip steps. It's going to do the thing you tell it to do. So an example of this logic in action could be something like all employees wear name tags. John's an employee, so John wears a name tag. That's an example of deductive reasoning. Now, here's the catch. AI doesn't actually understand the rule you're giving it. It just knows that in a broad sequence of text, when trained on text like this, then it applies the rule, right? And the good part about this with AI is it's always going to apply the rule. The bad thing is it introduces errors. So a human might notice something like this. John is off duty at a private event. So that means the rule doesn't apply right now, right? They can deduce that the rule, that the edge case doesn't apply. P.S. As you're watching this, I encourage anyone, let me know, do you think these 8 categories of reasoning are well defined? What am I missing? What is AI likely to do better than I'm implying? Help us all refine our thinking around this topic. It's a complicated topic and it's a quickly evolving topic. So I'd love to hear from everyone out there. How do you think about these things? So in this case, right, then the AI would make a mistake. And this is a weak point with models. Humans today, on the contrary, do this well, right? We are good at deducing things. Now, as we go on in the progression of AI, this is a category that is actually likely to get much, much better. And there's a few different ways that this is going to happen. The first thing is, and I'm going to try not to get too much in the weeds of all of this, but the first thing is what is being called in the industry, and by the way, help evolve my understanding of these technologies, is what's called symbolic solvers. And essentially what these things do is rather than, so within an AI model, what happens is it's trained on a large, volume of text. So as an example of this, it might say something like, if you were, when you are hungry, you should eat. But somewhere on the internet, it might also say, when you are hungry, you should, jump off a cliff. The AI could still give you that result because it doesn't actually understand what it's saying. It is simply saying in this sequence of words, these are the words that are likely to occur in this order. But based on the temperature setting, which is how the models are set to say, how should I use the most likely thing? Or can I also include the least likely things? It determines variation. Depending on how that temperature is set, it could also tell you when you're hungry, you should jump off a cliff. So what symbolic solvers are going to do is basically apply rigor to this process. They're going to make the AI not guess. And so the AI today is designed to sound smart rather than be smart. And the symbolic solvers are going to have a fact checker, essentially. So it's going to make it better. You're also going to have things like logic plugins, okay? And you're going to have things like agent scaffolding, which we're already starting to see. And then this is where the agent is going to start to be more rigorous in the way that these ideas are applied, because it'll break the problems into steps. It'll use tools. It'll insist that the work gets checked, and it'll fix mistakes. So why this all matters is right now, most AI tries once and then moves on. Just like if you use ChatGPT, it'll just give you an answer, right? It doesn't ensure that it's right or it's wrong. You can actually see in Grok, if you look at some of the reasoning in there, it does try to fact check itself right now, especially in Grok Heavy, if you prompt correctly. But over time, as this agent scaffolding gets layer in, it is going to get better at making sure that the deduction is right. So it's going to go plan, execute, checks, fix, submit, basically like run a process instead of just, this is the most next likely word. So if you think of this in plain terms, AI today is like this very confident intern, basically, right? That is just, it's sort of winging it, but it's like, it's going to give you an answer no matter what. It's going to be confident. And tomorrow it's going to be more like a co-pilot or like a very well-trained assistant. And so AI tomorrow, we'll call this green. Like it's going to be pretty good at deductive reasoning in the future with logic tools and so forth. All right. So next type of reasoning we've got here, and this is the one that AI is perhaps best at. And this is inductive reasoning. All right. Inductive reasoning is when we take a few examples and then we make a rule from it. So an example of this is you see the sun rise every single day. So the sun is going to rise tomorrow, right? This is induction. It's not a guaranteed thing, but we're inducing based on what has happened in the past, what is likely to happen in the future. Now, this is something that AI is really, really good at today because it's trained on these vast volumes of data. It is really good at seeing patterns of what has happened in pattern data sets, and then in inducing, it sounds like a weird, is that the right way to say it? Inducing what is going to happen next. So this is essentially the AI's superpower. And when you think about humans versus AI, humans are good at this, but they also have weak spots, right? Which is AI will never get tired. It will never skip steps if you give it a clear set of context and instructions and so forth. But here's a really critical distinction between AI and humans when it comes to this form of reasoning. And it's that AI doesn't actually know which patterns matter. It just knows what are patterns. So this is a reason why hallucinations can happen. Because you could just say like, okay, AI sees the sunrise, and then the sun rises and the sky is blue. And so the sky is blue must be part of the sun rising, because in syntax, that's what happens all the time. And so it's part of this rule when it creates the induction. And whereas we understand that there are independent independent variables involved here. And so this can create a lot of limitations, and we'll talk about this later, but it is stuff that is getting fixed, and this is going to get even better and better and better. I don't know, 2 greens here, right? As we train this thing on more data, even though there is limitations to that, and we'll talk more about that in a few minutes, as well as, like I said, we'll talk about how all this is going to apply to your job and so forth. All right, so our third kind of reasoning is abductive reasoning, which you can define as you make your best guess based on a limited set of clues. So you don't have all the facts, but you have enough to figure things out. So an example, you walk into your kitchen and there's an empty tray of cookies, and your kid's sitting there and he's got chocolate all over his face and there's crumbs on it, on the floor. And so no one will give you the answer. The kid is not going to tell you he ate the cookies, but based on abductive reasoning, you have a very high degree of certainty of what just happened with those cookies. The difference between AI and humans is that you are the parent who knows that this happened, but the AI doesn't have common sense, right? It's a robot, so it's going to scan through any relationship of data around these ideas, and within its range of training, it will pick up one of the variations based on the frequency in which it occurs. So it might weigh things like a squirrel ate it. It might, like, there's no way for it to abductively arrive at that conclusion. It is good at making plausible guesses based on these big training datas. Humans, this is one of the areas that we are really good at. And I don't just give humans green everywhere, by the way. We're not great at everything, though when you are well trained in narrow fields, especially, we really like our ability to reason is one of the things that makes us so unique on the planet. And for all the folks out there, no, I'm not saying we're the only, being capable of reasoning and rationality and so forth. A lot of this is being built into these machines, but right now we are the best at this. All right, so how AI handles this right now. Basically, it can simulate this kind of thinking, but very differently to us, because it's going to generate a bunch of possible explanations of, 10, 100, 1,000, and then it'll score them based on the frequency and the training data, and it's just going to pick one based on the patterns in the training data. But here's the big weak points here. It doesn't know when abductive reasoning is even needed, right? It doesn't know. It should guess what it should naturally do. If you say the cookies are gone, it might try to give you a recipe, right? Because my cookies are gone in the syntax. It might then what's trained most frequently is that you need a recipe. It doesn't know which guesses are plausible. It doesn't know when to stop basically going through the loop of what is a good enough assumption based on the things that are happening. And then it can also break when the clues are vague or they're phrased differently, whereas humans are really, really good at tolerating ambiguity. So what this is going to do in the future is we are going to have these agentic wrappers around AI where it's going to generate guesses, test them, check them, and revise again. And it is going to become more useful. It's going to become better at this, but it's still not going to know what feels right, which I know is like a murky term, but is actually the sum total of billions and billions of data points that you accumulate over your life that allows you to interpret reality, because you actually encounter reality, our physical reality in its manifestation here. And you build that model based on those encounters, not just based on language syntaxes in order. So I would give this, in the future, it's going to be like a yellow. Okay. It's going to get a lot better, but it's not going to be a green. And so why does this matter in a professional setting? When the stakes, when we really need the right answer in medicine or law or whatever, and we have these edge cases where there's ambiguity, AI can make a decision or a distinction that might sound logical, but it can miss a red flag that a trained person with a narrow specialization would instantly identify. And in the world, uncertainty is normal. I do think this is going to continue to improve. And if you were to say that humans make these kinds of mistakes too, I would agree with you. I still think at this stage, there's a reason you can look at the LLM when you work with these tools and you're like, that didn't make sense, right? That happens a lot when you work with these tools. And it's because the tools are still just next pattern predicting. Let's go to reasoning type number 4, which is analogical reasoning. All right. Analogical reasoning is when you solve a new problem by remembering a similar one, even if it looked totally different on the surface. So an example of analogical reasoning might be diagnosing a seal, right? So let's say you had a leaky faucet and you fix the leaky faucet and you figure out that the rubber coupling around the faucet was, faulty. And then later you find your air mattress is leaking air and you see that there's also stuff leaking out around the seal of the air mattress. So through analogical reasoning, you might say, okay, this looks like also a broken seal. And so let me see if I can fix the seal just like when I fixed the faucet. They look completely different. These things are unlikely to appear in syntax in a common usage, right, near each other. But you can see that this problem is kind of like that problem. And these are the kinds of leaps that right now AI really does not do well. So it's really bad at making this kind of leap right now. All it's good at doing is understanding what kind of word appears next in a sequence based on this huge volume of training data. So unless it sees this kind of combo around seal and faucet and leak and solution, it's not going to generalize across domains in the way that a trained person would. So you are going to transfer ideas. The AI is just going to transfer phrases. This is why I always talk about history rhyming. You try to create analogical patterns. If you look at top performers in a field, they're going to reference, this reminds me of this case or that case. It's analogical thinking to create bridges between disparate ideas. Now, AI is good at pattern matching, but only if they look the same, right? So if you give it a new problem that looks totally different, even though it's similar, it's going to struggle to abstract. So humans, on the other hand, to continue with our ranking here, are quite good at this. We are very good analogical thinkers. When you look at AI tomorrow, you're seeing a variety of approaches to improving this. There are things like multimodal training that's happening in GPT-4o and Gemini, where they're being trained on a variety of mediums, not just text, but images and code and video and diagram. Like they're increasing the training load of these things. So they might see structures. They're looking at things that are like called conceptual embeddings, right? Where they group by ideas by function, not just form. So you could have faucet and air mattress valve as things that control, flow, right? And the more of these functional groupings you have, the better the models will get. And then the agentic capabilities, as it gets better at running process to guess and check itself, it's going to get better at identifying these kinds of links. So AI tomorrow is still going to be better than this, but it's never going to be, or at least based on my understanding of where the technology is going now, it's not going to be as good as what humans are. And this ability is one of our most critical capabilities when it comes to creativity and flexibility and the ability to leap across different kinds of domains. So next is common sense reasoning. All right, common sense reasoning is using your basic understanding of the world to make sense of the situation without needing instructions. And an example of this would be, an elephant can't fit in a bathtub, right? You don't have to calculate this. You don't need to look up sizes or volumes or whatever. You just, because you've been absorbing this information since you were a toddler. And so as humans, we grew up in the real world where we have to interact with it. And then so we develop these common sense understandings. And so another example of this might be something like a phrase or like a common usage phrase, like he spilled the tea, right? You might know that it means gossip, not liquid. AI might confuse those ideas. So when it comes to common sense understanding right now, AI is not good at this. Now, humans, of course, I don't know, you could maybe argue this point, right? Of how good at common sense understanding we are, but I would say on a broad spectrum, we are good at this kind of reasoning within the practical domains of society. Now, AI is going to get tripped up, right? The reason it gets a red here is because it's going to get tripped up when things don't fit perfectly into language. So like an AI might think a laptop is going to put a computer in its pocket, because of the syntax of that word, stuff like this. Now, why does this happen mechanically? It's because it's ingesting words and developing relationships between those words. It's not grounded in any intuition of the real physical world. So it doesn't know that soap is slippery. It just knows the word slippery may come after soap. And this may change in the future, especially as some models get more grounded in physical reality. They're already starting to do some of this with robots, right? And to put some of these models where it's going to interact. We see this with self-driving cars, right? Where it's starting to interact with the world, simulated environments. So where I think this is still going to be a problem in the future, though, is that common sense is something that you really embody from experience. Like you spill the hot coffee and it burns, and that's something that you learn from the experience. It's not from textual correlations. And we don't tend to talk about things that we intuitively know to be true. And so when these models get trained, that lack of intuition is not out there to be trained on it. So all of the intuitive understanding that we have then needs to be documented and trained into the models on purpose, because we don't talk about these things in an external way in which we're going to ground these models in reality. And so while they may get better, like a lot of the things that just don't need to be said aren't said. And so they aren't baked into the models. And the thing about this is more data is just going to have diminishing returns without structure. So you're going to have to bake in things like, what does a bowling ball feel like? Like all these weird things that we take for granted as knowledge are just not reflected somewhere in training data so easily. Hey, if you're enjoying this video, would you take just a second and hit the thumbs up and subscribe? It's hugely impactful for the channel, and it helps me to continue to bring you content like this one. All right, we'll get right back to the video. And the risk of all this in the real world is that when it comes to common sense, we have it, but these models will fake it today. They'll just say something because it appears in sequence somewhere, even though common sense, it may not matter. Like it looks like it understands until it completely misses the boat. And there's obviously a bunch of high stakes setting where this is a very big problem because it's missing this worldview. However, as it gets continued evolution, it's going to get better and better and better at this. And so, yellow. All right, 6. And by the way, I do want to encourage you, if this is interesting to you and you're interesting, like all of this reasoning is fascinating to me. The bigger implications for all of us is, what does it mean for our life? And I am going to talk about what are the kinds of roles, especially in the future, that this is going to start to replace. If you're uninterested in the next 3 of these, you can skip to that part as well. So causal reasoning. Causal reasoning is understanding what causes what and why it causes it. So it goes beyond what happened and figures out what made it happen. And right now, AI is not good at this. It is correlation only. It cannot go to causation because it is just trained on these text patterns. Now, interestingly to me, I would say that in general, humans are also not that good at attributing causality, unless you are talking about specific narrow domains, which is why in all my work, I'm such a fan of specific expertise as a way to future-proof yourself. We'll talk more about that. But so you can think about causal understanding as something like your car won't start, right? So you might ask, like you might start to go through causality of, did you leave the lights on? Is the battery, like you're going to go through the potential causes of this. Right? You're not just going to like then list the parts of the car or whatever. So humans are going to think like detectives. We're going to try to go through the range of possibilities and probabilities, whereas AI is just going to say what has happened. So it's going to talk about if the, when battery appeared near to, dead car in a set of syntaxes. A very famous example, both with humans and AI, of where this would fail is something like, people eat more ice cream when shark attacks rise, right? So obviously the two have nothing to do with each other, but both happen in summer. And so it's like, ice cream consumption causes shark attacks. Common sense reasoning would tell us that's not true, but you could show the correlation and we could then leap to say it's causation in data. Right. So to wrap this up, LLMs don't build models of how systems work. They are not asking what caused X. They're just saying what is likely to appear in a sequence. Now, all this might continue to improve with additional causal models, with agent-based reasoning, and some of the developments we're seeing in the future. And I think that what I would give this here is a yellow in the future. I think this is going to get better. And I also think that this causality, by the way, is why it's so important to be expert in narrow domains, because your ability to assess causality, like a master mechanic would know exactly the syntax to go through to figure out why a car battery is dead. And this kind of specialty expertise is not just going to be broadly available to be trained. It's going to need to be specifically trained. And so your ability to know things that are not just generally available is going to be a huge competitive advantage. And this applies to any field. It applies to marketing, applies to car mechanics, it applies to plumbing. You can, apply it everywhere. Let's go 7. Temporal reasoning. All right, temporal reasoning is understanding how events unfold over time and how past, present, and future relate to each other. And so we're talking about sequences and timing. So one of the ways you can see this weakness in AIs right now is like I use AI. I help it create my running workout plans. And it's constantly screwing up the day. It doesn't know what day it is. It doesn't know what day yesterday was because there's no temporal reasoning going on. It's just next word predicting right now. And so right now, this is really not a good, there's ways around this, but it's not good at organizing things on a timeline. Humans, of course, are good at this, right? We live in space and time. So what's happening under the hood right now is it's just doing token sequences in words, and it's not simulating calendars or days or dependencies. It's just token sequencing. So that's why it's constantly screwing up what day my workout happened and so forth. However, this is another area where I think it's going to improve. And I actually think in this category, this is like a solvable problem. And it'll solve it by integrating calendars, by doing agent scaffolding. It seems to me that this is a solvable problem that's going to get better. And when you can even solve today by using a calendar as a training implement within your models to just make sure that it's referencing what's happened in the past accurately, not relying on its memory. So then let's go to our final category 8 so we can get into our 5 implications of this Math Olympics. Finally, we've got qualitative reasoning. This is basically how we make sense of things that aren't measured by numbers. And it's things like tone or taste or vibe or, does the design pop, which all designers love to hear, and so forth. And so it might be choosing between 2 different dishes at a restaurant, whatever, right? So if you think about how AI does this today, it's the same thing that we've said over and over again. It doesn't understand qualitative ideas. It is simply next token predicting. Humans, of course, this is the qualitative element of things is what we bring to the world. So AI is basically trained on descriptions of quality, not on the direct experience. So it'll understand if I label a thing with a quality, like this pen is black or a logo pops, but it's very difficult for it to incorporate all the different nuances of what makes that thing true. Again, why narrow expertise is so important, because you're better able to determine the quality of things. So one way that might, or that has been hypothesized that could fix this, is closed loop systems. So let's say that we had a headline. We were trying to figure out the best headline for a website. And we were going to do that by then writing 10 headlines, A/B testing them, and optimizing based on results. So AI could then figure out the best headline based on a specific set of criteria, like how many people clicked on a thing. But it's not going to be good in the broader evaluation of that thing. Like, so say you had Fiji water and you made the headline, one of the headlines was, then, 99% off. Well, you would optimize for that being the best thing, but does that then fit with the brand being premium and you wanting to talk about, where the water's from and the whole totality of the unmeasurables that go into the evaluation of this thing? It also, from this, is not going to invent what hasn't been done yet, because it's got to be tagged with a current state of a thing. So this set of qualities is something that will get better in the future as more and more qualities get labeled and more trends get modeled and so forth. But this narrow expertise in an area is what's going to make us so valuable in terms of our ability to understand the qualitative. Taste is going to be so important because you can't train these things on every qualitative idea. So let's talk about the math implications and what it really means for your job. And by the way, if you're still listening, thank you. And this is I know this is a complicated topic and I'm doing my best to distill it for everyone so we can all really understand what's going on here rather than just be dragged into sort of the hype. So what are these gold medals? It's not a sign of AI intelligence. What they are is a signal that they are becoming excellent pattern matchers when they are supercharged by compute in very narrow domains. They aren't mathematicians. They are just able to brute force problems over and over and over again with a set of logic until they get it right? And this is like, if you want to take it in a simple idea, right? What we have right now, think of AI as like an infinite intern. It's somebody who is never going to sleep. They're going to work at lightning speed and they're going to solve the hardest problems better than a human can because they're just going to go and go and go and go and go. And at first, this seems incredible, right? Because it's going to allow so much to happen faster. But the thing is that this intern, when harnessed properly, now works for all of us. And if we don't learn how to harness it properly, this is where we get left behind, right? And so here are what I see as the real world implications for our jobs. First of all, tasks that once required a human level of genius to sort of discern, like the gold medal Olympic thing, it's not going to matter. Like, can you win a chess match, right? Like AI can brute force these narrow ideas better than humans can. So knowing how is table stakes, right? It's not enough. You need to know the things around that, which is what to do, why it matters, and for whom, right? The broader strategic implications of what you're doing. Knowledge work as a whole, number 2, will be unbundled. And so what I mean by that is if these models can solve problems faster or more reliably than you, it's going to. And this is going to hit particularly hard in fields where there's like a lot of just stuff to get done, right? Like law, marketing, just like brute force copy, medicine in certain domains and so forth. And so what this means for you is here's what AI can't do. It can't frame the problem, not today. So you need to be really good at framing the problem. And what that means is you need to be really narrow in your expertise, in my opinion, because to be able to frame the problem of like why a specific weird kind of tumor is happening or a specific ad isn't converting or whatever requires really narrow domain expertise in a way that can't just be broadly trained by brute forcing the data. It requires very specific expertise. Number 3 is that human intuition is still going to be under-leveraged because all of this logic is going to start to get abstracted away from these models, but the taste and the discernment is going to matter more and more than ever before. It's not just like what is happening, but what needs to come next, what should happen, not just what can happen. So number 4 is going to be that everyone has the same superpower. We all have this infinite intern that's going to work with us. And so we are going to be the one who executes faster, who executes deeper, and who's going to ship smarter, who really understands the why. And so it's not just who accesses the tools, it's who knows how to use them well. And then finally, if you are just a pattern matcher, you're going to get automated away. So your real moat is in the synthesis, the storytelling, the communication, the thinking, and these broader skill sets are the things that are going like, what is the why behind the what? That sentence is going to change your trajectory. That's in the freelance formula. This is why I talk so much about narrow expertise, because your ability to go narrow on a specific subject and be the best at solving these kinds of problems, and this applies across domains, is what's going to future-proof and protect you. And by the way, 10x your earning capacity in a much lower amount of time, because you're such a specialist in this area where the problem solving can't be abstracted away. All right. So when this intelligence becomes the utility, then the discernment is what becomes the differentiator. That's the way I think about it. It's the taste at the end of the day that really matters. If you can ask better questions, why are we doing this? And what is the thing that actually needs to be done now? You will never be short of work. All right. With that, I hope you enjoyed this. If you did, all the good stuff, like and subscribe and watch the next video here also about AI. And with that, I will see you in the next video.